The time has come to talk about partial fraction decomposition. Partial fraction decomposition is a method that comes in quite handy when you have a fraction with some polynomial in the denominator. Like, let's say you had the integral of x divided by x squared minus 5x plus 6, with that little dx, of course. If we were to factor the denominator, we would get x divided by x minus 2 times x minus 3 dx. That looks like it would be pretty messy to integrate. It'd be really nice if we could break it down into two separate fractions, having something, let's call it a in the numerator, and just x minus 2 in the denominator. And having something else, we'll call it b in the second numerator, and x minus 3 in the denominator. But how do we get to that point? Well, let's take these two separate fractions and squish them into one fraction again. To do that, they're going to need to have the same denominators. So let's give them the same denominators by multiplying the first one by x minus 3 over x minus 3, and then multiplying the second one by x minus 2 divided by x minus 2. And now, once again, the two fractions are going to have the same denominator, so we can combine them to get a single numerator of a times x minus 3 plus b times x minus 2, all divided by that shared denominator of x minus 2 times x minus 3, with the little dx hanging out on the side. Ho ho! And now we have an equation, because we can compare these two integrals and see that we must have x equal to a times x minus 3 plus b times x minus 2. What should we do from here? Well, what if we set x equal to 3? Then we would get 3 equals a times 3 minus 3 plus b times 3 minus 2. And folks, what is 3 minus 3? 3 minus 3 is 0. And so we have a times 0, which is just 0. And all we have left is b equals 3. Yay! But how do we figure out a? Well, we can just try something similar. We can do x equals 2, which will get us 2 equals a times 2 minus 3 plus b times 2 minus 2, which is just 0. So that bro goes to 0. And we just end up with 2 equals a times negative 1. Or equivalently, a equals negative 2. Alrighty. And now we have our a and we have our b. So we can take our original integral, which was x divided by x squared minus 5x plus 6 dx. And we can rewrite it as negative 2 divided by x minus 2 plus 3 divided by x minus 3 dx. These guys are much easier to integrate. We'll just end up with negative 2 natural log of the absolute value of x minus 2 plus 3 times the natural log of x minus 3, all plus c. And there you go, a beautiful integration technique to add to your tool belt.